Welcome to the fourth part of module 6, which is granular look into whoops. So in our previous video, we have discussed how to write how to create a class, and then how to make instances, and how to write class attributes, and how to write instance attribute. To write instance attributes, we have used inbuilt init function. So now we will discuss about that inbuilt init function, and what are the ways, how many ways we can write inbuilt init function, and these kind of things in depth. So that's why I called it granular look into oops. So now let us actually deep dive into the oops. I think so far you got clear understanding of fundamentals of classes and oops. Again, class is a tool to implement oop. So these are not interchangeable. Class is a tool to make object oriented programming system possible. Now let us deep dive into, okay, before we enter into constructor. Now let us begin with the most important and most neglected topic, which is constructor, specifically Python constructor. So a constructor is a special type of method. Literally, it is a function which is written inside a class file, which is used. What is the purpose of this constructor? Basically, we are creating instance attribute using this, but the main purpose is used to initialize the instance members of the class. So then that's what instance attributes. Now there are two types of constructors, basically: parameterized constructor, non-parameterized constructor. The most important thing to be noted is when you call the class, or when we create the object of the class, at that time constructor definition is being executed. Okay, I will tell you, I will show you on in the code. Then so now how does this method look like? It is not a stranger to us, guys. This is nothing new. This is double trailing double underscore init leading double underscore method only. This method init simulates simulates the constructor of the class. As I have told you just before, this method is called or invoked when the class is instantiated. It also accepts the self keyword as a first argument, which allow accessing the attributes or method of class. That's what we said. It's we can use any word, but basically we follow self. We use self word frequently. So we can pass any number of arguments at the time of creating the class object, depending upon the init definition. It is mostly used to initialize the class attributes. Every class must have a constructor, even if it is simply relies on default constructor. But every class will definitely have this one. Even if you don't write it, if you pass it, still it will actually relies on default constructor. By default, we'll have one. Now let's take one example. Consider the following example to initialize the employee class attributes. Now we are becoming more realistic. Our examples are more realistic and more industry oriented. So class is our employee, name of the class is our employee, and now I used init trailing double underscore init leading double underscore function to add attributes. So one is ID and second one is name. These are the two attributes I have constructed using init. So that's why we call it as a constructor. We use constructor to make or to allocate instance attributes. So then again, now we have display method. In display method, what we have used, those instance attributes, that self.id and self.name, we have referenced here for the display method. So now we used employee call, that class call function call option to generate an instance or an object. The first instance is employee 1. His name is John, and then his ID is 101. The second instance is employee 2. His name is David, and his instance is 10. Sorry, his ID is 102. Then accessing display method to print employee 1 information. So you employee 1 dot display, you will get his information completely. So this is our output. So now what we have is we can counting the number of objects of a class. The constructor is called automatically when we create the object of the class. Consider the following example. Basically, this is a small example which counts the number of objects that have been created using that class. Class, I have taken student, name of the class is student, and class attribute count, that is 0 default, and then init constructor I have used the default one, self. I'm not attaching any variables in it. So now student dot count is equal to student dot count plus 1 and s1. So now I am creating s1, that's the first instance or first object. S2 is the second object, S3 is the third object, and when I print the number of students, comma student count, so when I execute this code, we'll get the number of students, because that's how we have written this class. Okay, now we will deep dive into the basically whatever we have seen before. Now it's just a fun hack to entertain you, nothing much. I will do it in Jupyter notebook also. That's why I just finish it. I have just finished it very quickly. Now and the non-parameterized constructor, uses when we do not want to manipulate the values are the constructor that has only self as an argument. So now we have seen what is a constructor and how can we generate an instance, how can we write an instance attributes using this. And now we will see various types of constructors. So the first, now in that list, the first one is non-parameterized constructor. Let's see how it looks like. Again, class is our student. Constructor type is non-parameterized. So self. So basically, if you do not put anything, then it's called non-parameterized constructor. On the other side, in contrary, the parameterized constructor has multiple parameters along with the self. So let's consider the following example. student class name, then type of constructor is parameterized, then init. So the first one, the first parameter inside, if you remember, I have explained this in functions module. The names that we send into a function, when you create a function, that time those names are called arguments, and the names that we send into a function when we call that function, those names are called arguments. So here, as we are creating a function, so now we call it as a uh, parameter. So when you include a parameter other than self, then it is called a parameterized constructor. uh, this is a parameterized constructor. So that's it. Then this is output we can see. The next what we'll see is, now we will look into Python default construct. When we do not include the constructor in the class or forget to declare it, then that becomes the default constructor. It does not perform any task but initializes the objects. So consider the following example: student, roll number is class attribute, name, that's Charan, that's also class attribute, display. See, I haven't written any constructor here, but when I use a method, at least I have to mention display. When I want to create a function inside that, at least I have to mention display, because by default Python writes a constructor, of course, which we can't see, but default constructor will be there with no parameters, only just self will be attached to it. So that's why we have to use self for whichever method we will write after that. So print self dot roll number and self dot name. So we'll get and then we'll generate an instance, and then we will apply that method to that instance, then we'll get a proper output. Then let us have a look at another scenario. What happens if we declare the two same constructor in the class? Let's see. This is very interesting scenario. Okay, let's see what's going to happen. Student, one is diff init, only non-parameterized constructor we have used. This is the first constructor. That's I want to that is what I want to print. And second one is also non-parameterized, and this is second constructor. Let's see what would be the output. The output would be the second one. Okay, we will see in the Jupyter notebook. That's fine. And finally, we will move. So in the above code, the object or the instance st called the second constructor, whereas both have the same configuration. The first method is not accessible by the st object internally. Internally, the object of the class will always call the last constructor if the class has multiple constructors. I hope you got the point. So let us have a look at, now what we'll do is, finally we will move on to some of the built-in functions to work with classes. So that is on right side here. So built-in class functions, we will discuss in detail in ahead of it later in this video. But for now, we will understand what is the purpose of that function. That's it, nothing much. The first most widely used function is get capital G, and get it's a small lower letter get. So it is used to access the attribute of the object. So you just give the object and then name, and it will give you the attribute. Then set attribute, it is used to set a particular value to the specific attribute of an object. Then del attribute, it is used to delete a specific attribute. then hash it returns true if it returns true if the object contains some specific attribute. So let's take an example. So here we have a constructor. Basically, it's a parameterized constructor. It consists of three parameters: name, ID, age, and on other side we have instance variables, that self dot name, self dot ID, self dot age. So now we have attached or linked that parameter inside the constructor with the instance variable so that we can use it in further. So now it creates the object of the class student. Let's create S is the instance generated from the student class. So name is Charan and ID and then age is 101 and 22. Now prints the attribute name of the object directly. So we can use get print get attribute, and similarly reset the value. Age is 22, so if you want to reset it to 23, use set attribute. And if you want to delete, so this is how it works. These are also very helpful. For now it is not that important. And more, so built-in class attributes now. So these are built-in class attributes. Double trailing underscore dict leading underscore. It provides the dictionary containing the information about the class namespace. And then doc, it contains a string which has the class documentation. Name, it is very important. It is used to access the class name. And module, it is used to access the module in which the class is defined. And basis, it contains a tuple including all base classes. So now, why late? Let's jump into the Jupyter. Jupyter, not planet. Jupyter notebook. Just kidding. Okay. Consider the following example to initialize the employee class attribute. Okay. So again, employee is our class. Inside that, I have used parameterized constructor. It consists of two parameters, name and ID, and self.id, self.name are the instance attributes. Now I have used, I have written a display function, and just self. I haven't used any parameters inside this function. I have directly taken from the top, because as self is there, it connects those to this function, self.id and self.name. If you want, if you add any other new parameter uh, such as age is done, ID is done, such as age here, then you have to give that age like this. But these instance attributes you can directly use by mentioning as self.id and self.name. So now we will create object, we'll create the object. So we have been creating or generating plenty of objects. No, it is not a rocket science for now. Different employees, and these are real world entities. Employee 1, his name is Ramam and his ID is 10010. Employee 2, he's also a real world entity. His name is Raghavam and his ID is 12310. Let's execute. Okay, let me execute. Okay, done. So now what we'll do is we will accessing display method to print employee 1 information. Let's print the employee 1 information. So employee 1 instance and display method. Let's see what's going to happen. So nicely structured, you see his ID is 10010 and his name is Ramam. Same we can do for the employee 2. Sorry. So now basically we have done one hack, a fun hack. Let's do it here. We will code it live. So I have a student class. It's up to you to use parenthesis, but I'm using. Now count is a class attribute. Then I have used non-paramet non-parameterized constructor, and then that student count. So this is the formula I have used. So now I have created, or sorry, I have generated three instances, and I want to calculate the number of instances. So the number of instances are 3. For example, if I execute S4, S5, 6 and then execute this, I will get 6 instances. So like this, if you use this small hack, you can actually track how many instances have been created thus far or so far. So till now we have been using non-parameterized constructor only. So that's the reason we will look into non-parameterized constructor also once. So non-parameterized constructor, again we'll take the student as our class, and then no parameters, only self, and then show self. So as we, it is a new parameters, it has, it is neither class attribute nor instance attribute. So that's the reason. So whatever you have mentioned here should be given here. Now I will generate first instance. So I got this because it is non-parameterized and I wanted to print this in this function. So when I generate this, this is what got printed. This is a non-parameterized constructor. Then we used a method attached to that, and let's call it. And the argument that I have sent inside that method is Bhima. Bhima. Let's see what it will give. It has given hello Bhima. So this is how a non-parameterized constructor works. Now we will move on to parameterized constructor. So far I think in every example, most of the examples we have used parameterized constructor only. So here we will have a one more look. Student, but here we have used only single parameter, and let me execute this. So I want to call this. So this is parameterized constructor. So when I give Bhishma Pita argument in when I'm generating class, in that case this Bhishma Pita will be taken by self.name, because see I have mentioned self.name. That's why I call it the instance attribute, the Bhishma Pitamaha. So when I execute the show, automatically it prints out the hello Bhishma Pitamaha. So now the default constructor, this is nothing. Don't add anything. That is a default constructor. If you don't add anything, then the Python itself helps you. That is helping you. So you have to thank Python for that. Okay, so I had just given class attribute and then two class attributes and then a display method. Let me check. And I have generated the instance S4 and display. Still it is working absolutely fine. So that means what is there behind? A default constructor is coming into the action. So then the problem with default constructor is you can't build your object attributes or instance attributes. Here all attributes are class attributes only by default. So that's the issue with the default constructor. Anyway, we don't use much, so just leave it. Then we are moving into more than one construct in single class. So here we have two constructors. First one, the first constructor, both are default, non-parameterized, and second one prints the second constructor. And let us execute and see which one is going to be in operation. So it is the second constructor. So the matter of fact is the object of the class or instance of the class will always call the last constructor if the class has multiple constructors. That we have discussed in our theoretical session of this granular look into oops part of module 6. Then I think finally we will look into built-in class functions. We'll take some examples. So I have written again the student class and then in it a parameterized constructor I have written self, and the name, id, age are the parameter, and the name parameter I have connected with the self dot name, and then id to the self dot id, age to the self dot age. So these are the instance attributes I am gonna use further in with my instances. So now create the object of the class student. So first student name is, first instance is Hari Home, his id is 102 and his age is 23. So I have created an instance. Okay, just a minute. Now get the attribute name of the object S. So how will you get it? Use get attr and name of the instance or object, basically object, and then what do you want, which attribute you want to get it. So that's the name. So I'll just type it, and then in the same thing, now here reset the value of attribute name age to 53. Okay, I have okay, self dot age, this age is the third one. So for that what I have to do is I have to give three arguments. Three. The first argument is object or instance name, and then second is which attribute you want to reset, and then third one is what is the value. So I will change it to 05 or just 5. Let's see. It's 5. Now its age got changed into 5. So now let's check the value whether it got modified or not. Here print the modified value of age. So for that I will use get attr and then instance name or object name and then age attribute. So change it to 5. But what I have given there was 50, but it has been changed to something else. And then 23, I gave 23, but now it is 5. Now one more hash attr, it returns true if the object contains some specific attribute. If it is not, false. So object name or instance name and then attribute in quotation marks. Let's see. Now I will give another another one. So id and the quotient. Let me check what we'll get. It's false. So that's what I'm saying. So with this we have reached the end of our session. So I would like you to request do a bit of practice on that, and in addition to that, just keep watching my videos and keep spreading love to all. And thank you, and I'll see you again in next session.